In order to be successful in your college mathematics courses, it's very important that you have a sound foundation in algebra. Now, it's a given that you have to know your arithmetic. So you have to know all your operations with fractions, decimals, and so forth. That's a given. In courses such as trigonometry or pre-calculus or even calculus, you have to have a good foundation in algebra. And the lessons that I'm going to give in this series here in basic algebra, this gives you the fundamentals, things that you need to know. Most of these things, if you take, for example, college algebra, your instructor is going to assume that you know these things. Okay, so hopefully this will help build that foundation that you need, especially if you're going to take several mathematics courses. So we're going to look basically at the factoring of polynomials, and I want to go over some of the main ways or methods that you're going to be using. Method number one is the GCF method, or the greatest common factor method. Whether you're dealing with a binomial or a trinomial, oftentimes you'll want to factor out the greatest common factor, and we'll look at examples coming up. If you're working with binomials, again, your first step is always going to be to see if you can take out a common factor, the greatest common factor. And then if you have a difference of squares, then difference of squares is always going to factor into the difference and the sum of the square roots. So we've got a squared minus b squared factors into a minus b times a plus b. And it doesn't matter what order you have this. You can have a plus b first and then the a minus b. Multiplication is commutative, right? 2 times 3 is the same thing as 3 times 2. Now, if you're again dealing with binomials where you have a difference of cubes, a cubed, for example, minus b cubed is equal to the difference of the cube roots, which would be in this case a and b. A minus b then would be one factor. The other factor would be the square of the first root plus the product of the two roots, a and b, plus the square of the second root, in this case b. Okay. If you're dealing with binomials, and in this case you have the sum of cubes, notice the two formulas are very similar except for some of the signs. So a cubed plus b cubed is factored into, first factor is the sum of the cube roots, a plus b, and then the second factor is the square of the first root minus the product of the two roots plus the square of the second root. When you're dealing with trinomials, probably the most common method that people use is the trial and error method, which we'll go over when we get to these. And if you have 3 or more terms, sometimes you're going to be using a grouping method. And we'll look at some of those in the examples that I'm going to work. Okay, so here we have factor each of the following. In this case, I have a binomial, 3x minus 12. So like I said, whether you're dealing with binomials or trinomials, the first method you want to try is, do we have a common factor? We notice 3x and minus 12, 3 divides into both the 3 and the 12. So that tells me that the GCF of those two terms is 3. So I take out the 3. What do I have left? Okay, well, I'm going to have left an x minus 4. And then you always want to, when they say factor, they always want the expression to be factored completely. So if you can apply some of the method, you go ahead and do it. In this case, that's as far as we can go. So 3x minus 12 is equal to 3 parentheses x minus 4. If you do the multiplication, you get what you started off with. Okay, we'll clear that. And let's look at the next example. Got 12x squared minus 5x. Again, it's a binomial, 2 terms. So we look at 12x squared the first term and minus 5x the second term, and we notice that each has a factor of x, so I can take out an x. That's my GCF. So I take out the x, and then what's left? Well, if this is an x squared, so this is x times x. If I factor out the x, that leaves me with 1x. Because x times x is x squared. I have a minus 5x here, so if I factor out the x, that just leaves me with a minus 5. Okay, and that's as far as we can go with this one. So this factors into x, parentheses, 12x minus 5. Okay, the next one, 25x squared minus 4, is also a binomial. And 25x squared and a minus 4, there's nothing common to both of these that I can factor out. So the GCF method in this case, I could only take out a 1, which doesn't do much for it. So the next thing I examine is that I have a difference of 25x squared. That's the same thing as 5x quantity squared, and 4 is the same thing as 2 squared. So here I have a difference of squares. So using the formula that I went over a while ago, when you have the difference of squares, it factors into the difference of the square root. So the square root of 25x squared is 5x. And the square root of 4 is 2. So this should factor into 5x minus 2 and 5x plus 2. Like I said before, you can write this as 5x plus 2 first, and then the 5x minus 2 second. The order of the factors does not matter. Yeah, so that's your solution for that. Okay, go to the next one. Again, this is a binomial, 2 terms. Now in this case, the first term is x to the 4th. Second term is minus 8x, so I see that I can take out of x from both terms. So that's your GCF for your common factor. So if I take out an x, okay, x to the 4th means 4 factors of x. So if I take out 1, that leaves me with 3 factors. So that's x to the 3rd. And then the minus 8x only has 1x. If I take it out, that leaves me with minus 8. Okay, so remember, I have to factor it completely. So this factors into x to the 3rd minus 8. But now the x to the 3rd minus 8, that's a difference of 2 cubes. So then I just put an equals here, and then I continue factoring. Okay, so I'm not going to do anything to the x, so I write that back down. But then I look at x cubed minus 8 as a difference of 2 cubes. So based on the formulas that I went over, this should factor into the difference. One factor will be the difference of the cube roots. So the cube root of x to the 3rd is x, and the cube root of 8 is 2. Okay, so that's the first factor of x cubed minus 8. And then the second factor, if you recall the formula, it's the square of the first root. Okay, so that would be x squared. And then it's plus the product of the 2 roots. So this is 2x. And then plus the square of the second root. So 2 squared is 4. So this is 4 right here. There you have it. Now, had this been a plus right here instead of a minus 8, this would be pretty much the same thing, except in this case it would be the sum of the cube roots. So this would be a plus right here. And this sign here, this sign right here in the second parenthesis is always opposite this one here. Okay, so this is a minus, x minus 2. This one will be a plus. Okay, so this one then factors into these three factors. The x squared plus 2x plus 4 is a trinomial. It's not going to factor. Any further, I should say. At least it won't factor over real numbers. Let me put it that way. So let's look at the next one. This one goes back again to binomial. I got 20x to the third plus 125. There's nothing common to both of these terms here. So the GCF is 1, so there's nothing I can do there. But I notice that it's a sum, and 27x to the third is the same thing as 3x quantity cubed, and 125 is the same thing as 5 cubed. So this is a sum of cubes. So this one then factors into the sum of the cube root. So the cube root of 27x to the third is 3x. And the cube root of 125, that's 5 times 5 times 5, is 5. So the first factor, then, using the formulas that I went over earlier, is 3x plus 5. And then in the second parentheses, the first term is always the square of the first root. Okay, so 3x quantity squared. 3 squared is 9, and x quantity squared is x squared. And then remember, the sign that follows is always the opposite of the sign over here in the first parentheses. So this should be minus, and then it's the product of those roots. So 5 times 3x is 15. X. And then it's plus the second root, square, or cube root I should say, squared. So 5 squared is 25. And this again is not going to factor. This factor turns out to be a trinomial, but it doesn't factor, and that's generally going to be the case when you work this type of problems. Oops, let me try this again. So that's 5 squared, 25. So those are the factors for that particular binomial. Clear it. Let's go to the next one. Okay, now this one's a trinomial. That is 3 terms. So again, the first thing I want to see is if do I have a common factor. And you can see that every term of the trinomial has a 2. So 2 is a common factor. Every term also has an x. And the smallest factor of x I can take is x. This is x to the third, this is x to the second, this is x to the first. So I can take out a 2x out of this. Okay, so if I take out the 2x, the first term is going to leave me with just an x squared. Okay, the second one, taking out the 2 and 1x, so this will give me an x. And then taking out a 2x, so this is actually 2x times 1. Okay, that's understood. So if I take out the 2x, that's going to leave me a 1. Okay. Now, this trinomial is not going to factor. If you tried to factor it in the standard way, this is what you would do. You would put out your two sets of parentheses and try to factor this. And here's the way it works. If this is going to factor, the first terms here have to be factors of the first term here, x squared. Okay, so the factors of x squared are x and x. And then these second terms of the parentheses here have to be factors of 1. Okay, so 1 times 1 is 1, so okay, we can try 1 and 1. And here's the deal. When you're factoring trinomials, if the third term has a positive, assuming the first term has a positive sign here, which it does, 1x squared, if the third term is positive, then both these signs here have to be the same. And they have to be the same as the middle term, which is plus. So the only factorization that I could have if this factors would be x plus 1 and x plus 1. But this is not going to give me this thing, because notice, if I multiply this, the x and the x would give me the x squared, obviously. The 1 times the 1 will give me the 1. But then when I multiply these two here, and these two here, this is 1x and 1x, 1x and 1x. This would have to be a 2 here for this to factor. So it doesn't. So the factorization for this is just 2x, parentheses, x squared plus x plus 1. And we clear this. And go to the next one. Okay. The next one is a trinomial again. So what do we see? We have 3x to the fourth minus 3x to the third, 36x to the second. So the highest power of x is x to the fourth, and the lowest power is x to the second. So that allows me to take out, I know I can take out an x squared. And all the terms are divisible by 3. So that tells me that I can take out a 3x squared. So look for the GCF, especially if you're dealing with binomials and trinomials. If the GCF is something other than 1, then factor it out and then apply one of the methods that I pointed out. So in this case, this leaves me with an x squared minus, okay, taking out a 3x squared, so this will be just x minus, taking out a 3, so this will be a 12. Took out the x squared, so I get this. Okay, so now you have to see if the x squared minus x minus 12 factors. If it does, you go ahead and factor it. If it doesn't, then that's the answer. But in this case, this is going to factor. Okay, so this is 3 x squared, and then this then is going to factor into 2 factors. And here's the way it works. The factors of the first term here have to be factors of x squared. Okay, so that's pretty clear. It's just going to be x and x. And the factors, or the second term of these binomials here, had to be factors of 12. So that means I can use 12 and 1. I can use 6 and 2. I can use 4 and 3. But remember, when I multiply it out, it has to give me this expression here. Okay, so I'm going to try 4 and 3. You're always looking ahead, and what the coefficient of this middle term here kind of will suggest what factors to use. And again, remind you that it's assuming that the first term of this trinomial is positive, okay, then the way it's going to work is if the third term is negative, then these are going to be opposite in sign. These have to be opposite in sign. If this is a positive here, if this minus 12 were positive 12, then both of these would have to be the same, and they would have to be what the middle term is. So this is a minus, this would be a minus, and this would be a minus. Okay, so the way it works, and I know that this is minus, so they have to be opposite. So this has to be a plus, and this has to be a minus, or this has to be a minus here, and this has to be a plus, opposite. Notice if I put a plus here, so let's do it this way. Let's suppose I put the plus here and a minus here. Always check yourself. So it's okay. X times x obviously is x squared, no problem there. 4 times minus 3 is minus 12, no problem there. But you always have to make sure you get the middle term. So notice in this case, when I multiply these two out to complete the multiplication, when I multiply those out, see, this is minus 3x here, and then this time this is 4x. If I add those up, that gives me a positive x. That gives me a positive x. So that tells me I have the signs wrong. Okay, so in this case then, what I want is I want this to be a minus here, and this to be a plus. That'll give me the negative term here. Okay, so that's what you have to play around with trinomials. Clear this. Now, if you have a problem where you have 3 or more terms, sometimes you're going to have to apply a grouping method. Okay. Now, obviously, if you have 3 terms, you look for methods for factoring a trinomial. Okay. In some cases, even with 3 terms, it could involve a grouping. But here's the deal in this case. So here I notice I have ax minus ay, I have a bx and a minus by, so I can't combine anything there. They're not like terms. So you're always looking to see if you can get something common. So sometimes you're going to group 2 terms together, and 2 terms, sometimes it could be 1 term by itself, and 3 terms together. Okay, so you kind of have to play around with it. In this case, it's pretty straightforward. Okay, this has an a and an a, so I can take an a out from the first 2 terms. Take out the factor of a. So what does that leave me with is x minus y. So grouping the first 2 together, this is what I can do. Okay, now the second terms, the second and the third term, notice over here, the third and the fourth term, I should say, both have a b. Okay, so I can take out a b out of those. So if I do, that leaves me with x minus y. Okay, so now notice, now this is really like 1 term, and this is a second term here. And notice I have a common factor of x minus y. Okay, they have a common factor of x minus y. So here I just apply the GCF method here and say, okay, let's factor out the x minus y. Take out the x minus y. Okay, so here, take it out. What do we have left? Well, that leaves me with a plus b. Okay, so that's what this factors into. So in this case, basically, I used the GCF method to factor the first 2 terms, and then apply the GCF method to the third and fourth term. And of course, it won't do me any good if when I do that I don't get a common factor. But here, notice I have x minus y, and x minus y is common. You bring that out, and that leaves you with a plus b. Put it in parentheses. That's your factorization. Okay, so that's your solution. X minus y, parentheses, times a plus b. Okay, the next one is again just a regular trinomial. I don't see a common factor. 5x squared minus 8x plus 3. There's nothing common there. So if this factors in, it should factor into 2 factors. And again, because the first term is positive, okay, so that means if the third term, which in this case is has a positive sign, both signs in the parentheses should be the same, and they should be the same as what the middle term is, which is a minus. So this should be minus, and this should be a minus. And then the factors of 5x to the second are going to be 5x and x. And the only factors of 3 that I can use are 3 and 1. Okay, so I can put a 3 here and a 1 here, 3 here and a 1 here, or a 1 here and a 3 here. So you have to kind of play around with it to see what works. Okay, so if I put the 3 here and the 1 here, and then do the multiplication, so you check it out. Obviously x times 5x is 5x squared minus 1 times a minus 3. See, signs have to be the same there in order to get this positive. So minus 1 times minus 3 is a positive 3. Then you always have to check for that middle term. Okay, so if I multiply these two out and those two out right here and add them up, it's supposed to give me the middle term. So that's minus 3 times x is minus 3x, minus 1 times 5x is minus 5x, minus 3x, and a minus 5x is minus 8x. Okay, so the solution is 5x minus 3 times x minus 1, both in parentheses. Okay, so let's go to the next one. Okay, so this one has 4 terms. So unlike the one I did earlier, number 8, I can't do the same thing here, because notice x squared minus a squared, nothing I can factor out there. This second term and the third term have an a factor there, but again, keep in mind that when you use a common factor method or GCF method, won't do you any good unless you get groups that have a common factor. So this is a case where I'm going to group 3 terms together and 1 term by itself. Okay, so I'm going to say, okay, this will be x squared, and then from these last 3 terms I'm going to factor out a minus 1. So that's going to leave me with a squared plus 2ab plus b squared. Okay, so now let me go up here. So this then is going to be x squared. Okay, so now this here in the parentheses is a squared plus 2ab plus b squared. That's a trinomial. So let's factor it as a trinomial and say, okay, the third term of that trinomial has a positive sign, so that means both signs in the parentheses have to be the same, okay? And they have to be whatever the middle term is, which is plus, so this would be a plus and a plus. Okay, the only factors of a squared are a and a. Okay, so the only option I have then is this has to be a and this has to be a. The only factors for b squared are b and b, so this has to be b and this has to be b. Okay, so let me just rewrite this for you then. But a plus b times a plus b is the same thing as a plus b squared. Okay, so now I've written this then as a difference of two squares. Notice it's x squared here and a plus b squared. So think of the first term as being the x and the second term being the a plus b. And let me fix this. This should be, the square should be outside here. There you go, like that. So it's the difference of two squares, and the square roots then are x and a plus b. So this then is going to factor into the difference and the sum of the square roots. So this then is going to be x minus a plus b, and x plus a plus b. Okay. And then to simplify it a little bit further here, then I'm going to write this as x. Let's see. This then, I'm just going to distribute this, the minus sign. So this will be x, and then just distribute the minus sign. So that'll be x minus a minus b. Now in the second factor, since the plus sign, I can just remove the parentheses there. That'll be x plus a plus b. Okay, so this then factors, the last one then factors, the solution then is x minus a minus b, parentheses, and then that's times in parentheses x plus a plus b. Okay, so this concludes this first lesson on just basic factoring. In the next lesson we'll continue with another lesson where you'll be using factoring to solve some other problems, and then we'll continue building on the foundation. Hopefully this will help you if you have to take say a college algebra class. So if these help you, please subscribe to the channel, and we'll see you in the next video.